This part we are going to run the classification of interest rate. Now we have a single payment, but it has different compounding interval. The example is that will the future value of lump sum be larger or smaller if compounded more often, holding the stated I% constant. What is lump sum? The lump sum means the single payment. As you can see, there is single payments at the current time. But we have different compounding interval. The first example compound annually, and second example compound semi-annually. How can you calculate this problem? Before solving this problem, we should know the classification of interest rate. This slide shows the two types of interest rate. The first one is nominal rate. It means annual rate that ignores compounding effect. We also call this the quoted rate or stated rate or APR, annual percentage rate. And second one is period rate. It means the amount of interest charged each period. It is used calculation, so we have the general formula like this. I per year is calculated by I nominal over M. M is very important concept of this. M is number of compounding periods per year. So M equal to 4. It means the quarterly compounding. M is 12. It means the monthly compounding. What about daily compounding? M is what? When you have daily compounding, M is 365. Let's return to this slide. What is state I? The state I means here, right? And nominal rate. And nominal rate has many names. The nominal rate, the quoted rate or stated rate, or APR. APR stands for annual percentage rate. As you can see, we have a single payment, but we have different compounding interval. So we should calculate the period rate. In this case, the period rate is same with the nominal rate because depending on this equation, the nominal rate is 10%. The M means what? M means the number of compounding periods per year. So in this case, 1. So it is 10%, right? But in this case, the APR nominal rate is same, but compounding number is 2, 1 and 2. So 5%, right? It is same with this. So when we compound more frequently, the number is more larger. Because as more frequently compounding occurs, the interest is earned on interest more often, right? Or more often, so it has more value. So finally we get the conclusion: when we compound more frequently, the future value becomes more larger. This slide shows one more concept of interest rate, the EAR. The EAR stands for effective annual rate. It is annual rate concept, but it accounts for compounding effect. This is different with the nominal rate. As we learned before, nominal rate, it ignores compounding effect. Let's say we have $1 today. Let's draw our timeline. And the semi-annual investment. So at 6 months, this money compounds 1 time and 2 times. And on the timeline, there is period rate. Let's say 10%. Yeah, here this means the nominal rate. So we should calculate period rate. Period rate is nominal rate divided by m. So in this case, nominal rate is 10%. The m, the compounding interval, compounding period is 2, right? So period rate is 5%. So that is 5%, 5%. Now we want to know the annual rate, the interest actually being earned, accounting for compounding. How can you calculate? Yeah, is that same with this? No. Now we want to know what rate shows the accounting for the compounding effect. Let's find this. This timeline can be calculated by this. The future value is 1 multiply 1 plus 0.5. How many times compound? 2 times, right? And this timeline, it shows this. The question mark is EAR, right? So EAR can be calculated by square, right? And subtract only 1. This side goes to left hand side. And that is this number. And this is 10.25%. Yeah, it is different with this, right? Because this number accounting for compounding effect. EAR has some general formula, so you can easily calculate this. EAR is equal to 1 plus nominal rate over m. M means compounding interval, compounding frequency, and power of m minus 1. As you can see, this is same with period rate, right? So we can write down shortly as this. So now we can interpret the receiving 10.25% annual interest. It is the same with receiving 10% interest compounding semi-annually. Why is it important to consider the EAR, the effective rate of return? Because nominal rate does not have so much meaning, because nominal rate does not consider the compounding effect. But in the real world, each investment project can have different compounding interval. So when you have the single payment with different compounding interval, EAR is good to compare each investment project. As you can see, compounding more frequently. This is annual, quarterly, monthly, daily, and continuous. as you can see, the numbers getting higher, right? So compounding more frequently, EAR gets more bigger and bigger. So we convert to EAR for the comparing. One interesting is here, the EAR continuous. It means compounding continuously. How can you calculate this? EAR can be calculated by using this formula, right? 1 plus I nominal rate over m multiply, no, power of m minus 1, right? But we have many m, right? The m means number of compounding interval. So we have a continuous number. How can you calculate? Yeah, in the high school, we was learned this equation. When n goes to infinite, one plus a over n power of n is what? Do you remember? The Euler's number, e to a. So in this case, take a limit, m goes to infinite, and then finally we get e to I nominal rate minus 1. So e is, it has number 2.7182818 and many numbers, and we can simply calculate using Excel the exponential I nom minus 1. In this case, the nominal rate is 10%, right? So it has this number, 10.52%. And you don't have to remember this. I just show you how to calculate when you have the continuous compounding intervals. When is each rate used? Firstly, the nominal rate written into contract quoted by bank and brokers. Especially in the bond brokers, they usually use nominal rate. It is not used in the calculations shown on timelines. And second, the period rate we used in calculations and shown on timelines. So we usually use period rate when you have some questions. So if m is 1, it means compound annually, the nominal rate and period rate and EAR, effective annual rate, is same. You can simply understand like this. Just write down the equation. Yeah, EAR, the equation is 1 plus nominal rate over m power of m minus 1, right? And it can be also write down period rate power of m minus 1. So in this case, if the m equal to 1, this is I nominal rate and this is I period rate, right? So you input the m equal into one number, you get this result, right? And finally, EAR used to compare returns on investments with different number of payments per year. Especially, it is good to use the single payment with different intervals. In other case, sometimes using EAR is hard. So I recommend you draw a timeline first and then find the period rate. It is more good to solve the problems. One example to calculate the semi-annual compounding and quarterly compounding using period rate and EAR. So what is future value of $100 after 3 years under 10% semi-annual compounding? And also calculate quarterly compounding. In this case, I recommend you draw a timeline. It's good to understand. So let's draw. There is 3 years, right? And semi-annual compounding. So compound at 6 months. 6 months, right? And what rate we compound? This rate? No. This rate is the nominal rate. But in this case, on the timeline, we should calculate the period rate. And period rate can be calculated by nominal rate over compounding interval. So in this case, nominal rate is 10% and compounding interval is semi-annual, so 2. So period rate is 5%. So we compound 5%, 5%, 5%, right? And now we have $100 and we want to know the future value. So the future value is can be compounded, right? $100 period rate. How many times compound? 1, 2, 3, 5. No, 1, 2, 3, 4, 5, 6, right? 6. So you get the numbers, right? And you can also calculate what rate here. Here is EAR. Yeah, single payment, but we have the different compounding interval. So in this case, we can use EAR. So EAR can be calculated by 1 plus I nominal rate and divided by m power of m minus 1, right? And we can also write down this period rate power of m minus 1. We already calculate the period rate. Period rate is 5%. And number of compounding interval is 2. And finally we get the EAR. EAR is 1025. So you input the EAR, you get the same number. This is for the semi-annual compounding. I erased some numbers. This is second example, the quarterly compounding case. So let's draw a timeline. So you have $100 today and invest 3 years. But compounding quarterly, so in the 1 year compound 4 times. Yeah, every 3 months, right? And how can you calculate the future value? As I mentioned before, you should calculate period rate first. So nominal rate is same, and m is what? 4, right? So the period rate is 0.025. So the input number is here, right? How many times compound? Yeah, 4 times in a year, and we have 3 years, so 12 times. what about EAR? Yeah, there is a single payment here, so we can use EAR also. So in this case, the period rate is 0.025 and M is 12, right? And minus 1. Not 12. This is 4, right? Because compounding interval in a year. So 4. So you get the number 0.1038, right? And it is same with this number, right? Yeah, 10.38%. Yeah, this is also 10.38% because we assume the same nominal rate, the 10%. So if you input this number here, you get the same result. I show some questions. Can the effective rate ever be equal to the nominal rate? If yes, when? Or if not, why? We already run this part here, right? The EAR can be same with nominal rate and period rate when m equal to 1. What does it mean? M equal to 1. M equal to 1 means compound annually, right? So the answer is yes. When compound annually. This is the answer. This is the second question, but it's tricky. So I recommend you have a few minutes to think about. A quoted interest rate is 10%. What does it mean? This means nominal rate. But it compounds semi-annually and 3-year ordinary annuity. In this case, you can easily understand using timeline, right? So let's draw timeline first. We have 3 years and ordinary annuity, so payment occur here and here and here, right? But it compounded semi-annually, so you should calculate period rate first. How can you calculate? Period rate can be calculated by nominal rate divided by m. So nominal rate is 10%, m is 2, right? So period rate is 5%. And then at the year 3, this money is the same, but this money has more number, right? Multiply 1.05. How many times compound? 1 and 2, right? And this money 100 multiply 1.05. How many times compound? 1, 2, 3, 4. And then sum of these 3 terms, 1, 2, 3, you can get the numbers. That is the future value of this ordinary annuity. As I mentioned before, when you have some problem, you can draw a timeline and calculate the period rate first. That is a simple way to understand these kinds of questions. How about this case? This cash flow divided by 2, the 50 and 50. So we can write down as this. Is that right? No. because you cannot change cash flow of the timeline. So it is important to check the frequency of cash flow. The frequency of cash flow. Yeah, that is important. Method, we already learned the general formula of the future value of ordinary annuity, right? So we can use that general equation. The general equation we get here, right? So we use this equation. So the FV of annuity, ordinary annuity, is here. The PMT over I 1 plus I power of n minus 1, right? So the input the numbers, the PMT is 100, and I, what is I here? Is that this number? We compound semi-annually, the nominal rate 10%, so 0.05, is that right? I just write down 1 plus 0.5 power of n is the semi-annually, but we have 3 years, minus 1. Is that right? No, because the frequency of cash flow is annual, but the compounding interval is semi-annual. So in this case, the I should be EAR, because the frequency of cash flow and compounding interval is different. So how can I calculate the EAR? EAR can be calculated by this formula, 1 plus I period rate and number of compounding periods minus 1. So we already calculate period rate here, right? So I 0.05. What is M? Yeah, we compound semi-annual, so power of 2 minus 1, and we get the number 0.1025. So the payment is 100, the I is EAR, what is N here? So EAR is annual concept, right? So we have 3 years, so the power of 3 minus 1. That is answer of this. Maybe you can have same numbers from this calculation, and when you use period rate, you can also get the number, right? So you have the same number here and here. This is the opposite example. Now we try to find the present value, and we compound semi-annually, right? So let's draw a timeline first. Zero, 1, 2, 3, but we compound semi-annually. So we have 100 in time 1, 100 at time 2, and 100 at time 3, because it is ordinary annuity, right? And now we want to calculate the present value, but it compounds semi-annually, so every 6 months we compound. And as I mentioned before, you can calculate the period rate, right? The period rate was 5% here, right? So 5%. So just discount it. Discount this number. 100. The period rate is 0.05. 1045. And what is power of n? Discount how many times? 1 and 2. So power of 2. And this money discount how many times? 1, 2, 3, 4. Power of 4. And this money discount 6 times, right? And sum of this, that is the answer of this question. It's simple, right? You can also use the present value general formula. As we learned before, present value of ordinary annuity can be calculated by this general formula, right? So write down the equation. The present value of ordinary annuity can be calculated by payments over I (1 minus 1 over 1 plus I power of n), right? And what is I here? What is I here? Yeah, it's EAR. As I mentioned before, we have annual cash flow frequency, but the compounding interval is semi-annual, so we should make it same with the frequency of cash flow. So the I is EAR. We already calculate this EAR, right? So input the payment. The EAR was here, right? So write down what is power of n? Power of n is 3, right? Because EAR is yearly concept. And finally you get the number. At the previous case, the number is 331.8. And this case, the number is 247.59. And that is the answer. You can also use the Excel function, the PV, and the firstly you input the rate, right? In this case the rate is EAR, so 0.1025, and number of periods, EAR concepts, so number of periods 3, and the payment is 100, and FV, there is no additional cash flow except the payment, so 0. And then you get the same number with this. Back to slide number 20. Number 20, the example is here. This example. One thing I would like to tell you, I had some mistake. There is no cash flow at Mike just turned to 20 years old. So there is no cash flow. Cash flow starts when he is the 21 years old. So now every day Mike puts $3 in her saving account with an expected annual return of 12%, compound daily. That is important. How much money will he have when he is 65 years old? It looks complex, so what do? Let's draw a timeline. He saved daily, right? So compound daily time. So this year 45 years, but he invests daily. So and day one he inputs $3 in the saving account. And many days, right? And now we want to know how much he really have. So the future value, right? How can you calculate this? Yeah, firstly you should calculate period rate, right? This period rate. The period rate can be calculated by nominal rate over M, right? The nominal rate is 12%, but we compound 365 days, right? So that is period rate. So this money can be compounded how many times? Yeah, 45 multiply 365. Is that right? No, just minus 1. Yeah, because compound starts here, right? And repeat all the cash flow and $3. And then sum of them, that is the answer of this. But it's hard to calculate, right, using by hand. So now we can use the future value of annuity function, annuity formula. So the FV can be calculated by PMT over I 1 plus I power of n minus 1, right? In this case, the payment is what? Yeah, $3. And what is I? Can you use what rate? So in this case, the frequency of cash flow is daily, right? But the compounding interval is what? Is daily. It is same. So in this case, what rate we use? EAR or the period rate? Yeah, period rate. We cannot use EAR in this case because EAR is annual concept, so we should consider the frequency of cash flow. At the previous example, the frequency of cash flow is annual, so in this case we use EAR. But this case, the frequency of cash flow is daily. So in this case, we use just the period rate. So what is period rate? Yeah, we already calculated here, right? So the payments is 3. The period rate is 0.12 divided by 365, and the I is same, right? 0.12 over 365. And what is n? 365 multiply 45 or 44. 45. Because according to the sum of geometric sequence, that is number of terms, right? So in this case, it means the total number of dates and minus 1. That is the answer of this question. You can get the number 2009416.34. That is the answer of this. You can also use Excel function. The FV is equal to 0.12 over 365. This is the rate, and number of period is 365 multiply 45, and payment is 3, and there is no PV. PV means the cash flow at the current time. There is no cash flow, so it is 0, and then you get the same number as this. It's different between question number 2 and 3 and 4. Question number 2 and 3, the frequency of cash flow occur annual, but the compounding interval is semi-annual, right? But question number 4, the frequency of cash flow is daily, and compounding interval is also daily. So the difference is the period based on payments occurs. In this case, the frequency of cash flow occur annual, so we can calculate EAR. But in this case, the frequency of cash flow occur daily. In this case, we can calculate EAR, but it is very hard to calculate. So I recommend you use the period rate. So the easiest way is to check the cash flow. And check the cash flow. No. Check the frequency of cash flow, and then you make everything consistent with this frequency of cash flow. It means drawing a timeline and then find and check the frequency of cash flow and then calculate the period rate. And some of them, that is the easiest way to calculate the answer. As I mentioned before, the present value of cash flow, which we estimate, is valuation of the bond and stock. This is the rest part. Thank you.